plus the centroid. But we also discover that when Q is above centroid, it is what? Positive, and Q is below centroid, it is what? Negative. Either one. Okay. The answer will be the same. Okay. Then rule number 5, okay, is Q can only flow in what? One direction. And why we say that? Because when we started our what? Started deriving, right? Remember this diagram? And we say that this is Q. Our Q is in one direction. Okay. And then number 6 that we remember, okay, that we have is the thickness T, or thickness T, okay, is perpendicular is perpendicular to the shear flow direction. Now, all these rules still apply in thin wall analysis. Okay. So, what is this extra add-on? Okay. What is this extra add-on? Okay. So, in thin wall analysis, okay, there are two general configuration. Okay. The first one is what we call the box beam. Now, this is, you only use this in thin wall analysis. I repeat again, we only use this in thin wall analysis. Okay. In non-thin wall, this will not apply. Okay. So in thin wall analysis, there's box beam and white flange. Okay. So what is the difference between the thin wall and the white flange? Okay. So over here, right, there's one diagram, and then there's another diagram over here. Okay. Right. So what you see over here on the left is what we call the box beam. And on the right is what we call a white flange. Okay. So there are a few things that I want here to that I'm going to introduce to you, right? Over here, these dot over here are known as terminal. And over here, this is our terminal number 2. Okay. So that's for box beam. For white flange, you have 4 different terminals. So you have terminal number 1, terminal number 2, terminal number 3, and terminal number 4. Okay. So at the terminal, okay, for both cases, at the terminals, okay, the shear flow either ends or start. Okay. That's why for the box beam, right? At point A, the terminal, this terminal is the start. Terminal 2 is the what? Is the end. For wide flange, terminal A and A prime are the start. E and E prime are the ends. Can you see that? Okay. Those are, so at the terminal, okay, at the terminus, the Q is equal to what? To 0. Okay. I repeat again, the Q is equal to what? To 0. Okay. There are certain parts that I want you to like recognize. Okay, there's a certain feature that I want you to recognize. This thing that starts from the top, hold on. That starts from the top, that starts from the top. They're highlighting in yellow, and ends at the bottom. We call this major web. Okay. Then again over here, this over here, they're highlighting in yellow, right? That starts from the top, okay, the top end and the bottom end. This is our major web. Okay. So another thing that you see is what? The major web is continuous from the top to bottom of the structure. Okay, it's continuous. It cannot have any breaks at all. Okay, and what we can see over here is the major web controls the direction of the what? Shear flow. Okay. Now, what do I mean by that? The major web controls the direction of a shear flow. So now, if we have a section now, okay, I'm deliberately drawing a box beam section. Right? Okay. So I'm going to have 2. I'm going to have 3. Okay. So if the Vy starts from the top, right? The shear flow, so the major web, I'm going to highlight the major web in yellow now. Okay, so this is a major web. This is the major web. These are all your major webs. Okay. The major web controls the direction of the shear flow. No, this one later. Okay. Right. So when that's the case, right, knowing that this is our centroid, right? The shear flow is like liquid flow. Okay. So we can see on the left column, extreme left column, right? It's coming down. So the shear flow will be in this direction. Then over here, this is our terminal number 1. At the bottom, this is our terminal number 2. Okay. So this is thin wall, box beam, thin wall. Now, it states that the thickness is perpendicular to the what? To the shear flow. So if you were to consider what is the thickness, this is known as our thickness. This is known as our thickness. This is known as our thickness. Why? Because the thickness is perpendicular to the what? The shear flow, right? So that is our thickness. Now, if we have Vy, right now, if we have Vy in this direction, right? So now, again, the major web controls the shear flow. And this is our terminal. So this is our terminal number 1, terminal number 2, right? And then again, the thickness go this way. This is our thickness. Okay. So this is again box beam, thin wall. Okay. Again, this is our centroid. Now the third one I'm going to draw, right? So this is our Vy. What if it is non-thin wall? Right? We just came from there. Yes or no? If it's non-thin wall, what will happen is this surface is our terminal. And this surface is also our terminal. Remember, when I started this course, I mentioned what? The terminal can be a point or can be a plane. For this case, non-thin wall, it is a plane. So this is our terminal number 1 and then terminal number 2. And then if we design our shear flow, this is how our shear flow look like. Wrong direction. Come on. Let me. Unbelievable. Yeah, so this is our shear flow. Remember, right? And then the thickness, depending on what we want, okay, this is our what? Thickness. Over here, then this is our thickness. And over here, this is our thickness. So there are some similarity and some differences, and we'll do that after our break. Okay, so go for a 10 minutes break and we come back.